right, last thing for chapter 3 is word problems. And we're going to think about things that could happen in real life that will look like the slope-intercept form of a line if we put it in equation form. So we've already been talking about independent and dependent variables. The independent variable here is the x because you pick your x's. The dependent variable is the y because it depends on what x is. We're going to go through and notice that the rate of change is always what the slope is. And that the starting point is always what the b is. So the y-intercept. So it's hard to see that until you do an example. So here's our first one. It says, Mr. Hubert collects hats. He has 6 hats already, and he's going to collect 2 hats a week. So it's like, okay, if I put it in terms of hats and weeks, he starts out with 6 hats. So he's got that to begin with. And then every week, he's going to gain 2 more hats. So he'll add 2 hats for every week, and that'll tell you the total number of hats. So personally, I would like it in terms of like how many hats he has is 6 plus 2 times every week he spends. But we're probably going to put this in slope-intercept form with y's and x's because that's what you're most familiar with. So we're going to say 2x plus 6. So it says, what's the equation that represents this information? Where the y is the number of hats he has. The 2 is the rate of change. He gains, I guess gains may not be the best word, gains 2 hats every week. The x is the number of weeks that pass. And 6 is the number of hats he had to start with. So when they say, does the scale of 1 work for our graph? If we're graphing y equals 2x plus 6, then yeah, a scale of 1 works just fine because y-intercept, let's say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So he has 6 hats to start with. He gains 2 a week for every week. Oops. And there's our line. So sure, talking in terms of 1 hat, 1 week, that works fine for our graph because down here, these are our x's, these are our y's, but our x's are the number of weeks that pass or go by. And this is the number of hats Mr. Huber has. So how many hats would he have at the end of week 2? So if the x stands for the number of weeks, let's figure out what the y is when we plug in a 2. He'd have 10 hats. How many would he have? What's the y when you plug in a 4 at the end of 4 weeks? He'd have 14 hats. Okay, all right, here's another one. Oh, I got a typo. Darn it. At Joe's Clown Car Rental Agency, renting a car costs $25 plus 75 cents for every mile driven. So it just flat out costing $25. So I'd say like the cost is, it's going to be $25 plus 0.75 cents for every mile. So I'm saying C for cost, M for the number of miles driven. But if we want to make it like y equals mx plus b, we can go y equals 0.75x plus 25. So what does the y represent? Y would be the cost to rent the car. in dollars. The 0.75 is the rate of change. It costs 75 cents per mile to drive. What does the X represent? It's the number of miles driven. And then what's the 25? That's just the starting point. That's the starting cost. So it's the cost to rent the car before mileage is figured. Okay. All right. Does a scale of 1 work for a graph here? Probably not. Because if you're saying it costs $25 to start, and we're going to graph y equals 0.75x plus 25, you don't want to count by 1 all the way up to 25 for that y-intercept. Maybe we count by 5s. And there's our y-intercept. And then maybe it's like the number of miles driven. I don't know, think about how many miles you're going to drive. Just coming to work this morning, I drove probably 15. So maybe we do something where, I don't know, we count by 50 or 25, maybe 25 down here. So our X's are the number of miles driven. And our Y's are the total cost to rent the car. And now think of this. If you got 0.75, that's 3/4. So I'm going to put a y-intercept 25. I'm going to rise 3, run 4. But that's kind of hard to think about when you're counting by 25 for every one of these blue blocks here and 5 for every one of those blue blocks there. I would probably do this instead. If a clown drove 100 miles, how much does it cost? So what's the cost if it's 100 miles? So let's go 0.75 times 100 plus that extra 25. So there's $75 plus 25. It's going to cost you $100. So 100 miles cost $100. Ooh, I don't even like, because I can't fit that on there either. Maybe we don't count by 25s. Maybe we count by 25s, like 25, 50, 75. 100. Then we got a y-intercept. And when we plugged in 100 for the number of miles, we got out $100 for the cost. So 100 and 100. And then we'd have our line because we had found a second point on it. So you can do that. Down here, you've got 150 in savings, and then you're going to save $40 a month. So your savings, you start out with 150, and you add 40 for every month that you save. So what's the equation? So if we do y equals mx plus b, we'd make it 40x plus 150. So the y is the dollars in the savings. 40 is the rate of change, because you save $40 per month. The X would be the number of months you've been saving. And then the 150 is the opening balance. It's the starting point. It's what you opened up your savings account with. So X is number of months of savings. Y is dollars in the savings account. And how much will you have in your savings account within a year? So a year is 12 months. So let's see what y equals when I plug in 12 months. So it'd be 40 times 12 plus that extra 150. So that's 480 with an extra 150, $630. So number of months, maybe we do like 2, 4, 6, 8, 10, 12. And how much money you got? I don't know, maybe $100 at a time. 100, 200, 300, 400, 500, 600, 700, etc. So we start out with 150, and then you're going to save 40 a month. But let's see. So if you rise 40 and run 1, somewhere around in there. We said 12 months, you're at 630. So about right there. So this one we counted by 2s on the x-axis and 100 on the y-axis. You can count by whatever you want as long as you keep it consistent per axis. And it's, it may feel weird not counting by 1s, but that's okay. You can do that.